So, hello everyone, my name is Abhinav Kishore Shangote from MIT Academy of Engineering Department of Computer Engineering. So today I am going to explain the topic optimization of loss function and the best fit line using gradient descent. So this topic is a part of our subject exploratory data analysis. So in this presentation I will explain what is regression, what a loss function means, and how the gradient descent algorithm helps us to find the best fit line. So let's begin. So this is my information about my college and my name and the roll number. So let's begin with the introduction. So introduction to regression. So regression is a supervised learning technique that helps us predict a continuous output value. It finds a relationship between an input variable x and y. The general equation of a straight line regression model is y is equal to mx plus c, when m is the slope and c is the intercept. Our goal is to choose m and c so that the line fits the data points as accurately as possible. So here is intro about the regression. So the main equation is a y is equal to mx plus c. So let's begin with next slide. So what is the best fit line? So a best fit line is the line that passes through a data in which in such a way that the total difference between the actual point and the predicted point is minimum. In the scatter plot, some plots will be above the line and some plot below it. But overall, this line captures the trend of the data. The smaller the difference, the better is the fit. So in this slide, what is the best fit line? So the number of a point passes through the line is a fit line, and the best is that line is a minimum error. So next slide, understanding errors. So error, the difference between the actual and predicted value is called the error or residual. So mathematically, the error is equal to y actual minus y predicted. So in our model predicts very well, this error will be very small. If the error is poor, the error will be large. So our target is to reduce this error as much as possible. So that's all about this slide. So let's begin with another slide. So what is loss cost function? So to measure how well the model fits all the point together, we use a loss function, also called a cost function. Our common example is the mean square error, which is written by j in bracket mc is equal to 1 upon n summation of n, where I is equal to 1, uh, in bracket yi minus in bracket mxi plus c, bracket square. So this formula calculates the average of the square error for all points. A smaller j means a better model. Therefore, our objective is to find m and c that minimize j. So the next slide is optimization concept. So the process of finding the best m and c values make a loss function minimum is called optimization. So there are many ways to optimize, but one of the most popular and efficient method is gradient descent. So the gradient descent updates m and c step by step until the loss is small as possible. So next slide, gradient descent introduction. So this slide is whole about the gradient descent introduction. So gradient descent is an interactive optimization algorithm. We start with random values for m and c and compute the loss. Then we calculate how the loss changes with respect to m and c. That change is called the gradient. So we then move m and c a small step in opposite direction of the gradient, meaning downhill, to reduce the loss. The process repeats until loss stops decreasing. So we can continue this process until our loss is get decreased. So next slide is gradient descent formula. So there are mathematical rules is equal to m nu is equal to m old minus alpha del j upon del m, and the c new is equal to c old minus alpha del j upon del c, where alpha is equal to learning rate and del j upon del m and del j upon del c is equal to gradient of j. So if alpha is too large, we may skip the minimum point, and if it is too small, then it will take a long time to reach the minimum. So choosing the right learning rate is the important. So use the formula 1000 and C, and then update M and C. As the loop runs, the loss decreases and the line becomes the best fit line. In the real project, the same logic is used inside the libraries as scikit-learn and TensorFlow. So next slide is conclusion. Uh, to conclusion, it regression help us understand that the relationship between the variables. The loss function measures how accurate our prediction are. Gradient descent is an optimization technique that maximizes the loss function by updating parameters step by step. Finally, when the loss is minimum, we obtain the best fit line that gives the most accurate prediction. So, in conclusion, the gradient descent gives the most best fit line, uh, so we can accurate more predictions. So, thank you for watching my prediction of an optimization of a loss function and the best fit line using gradient descent. So, thank you.